First, of course, this is my leading coefficient. We'll play a part later on. The highest exponent is the degree. The degree goes down, decreases, descending order, until you reach a constant, if there is a constant, on that polynomial function. That's the form they take. Gee, did they say anything else on that form, or did I say anything else on that form at this moment? No, I just gave you the form. Here we go. Into it here. This n, this degree, and it drops down one, the exponent. They're saying, yes, the n must be this type of a number. Which means 0 will keep those exponents to be positive. Greater than or equal to 0. Could be 0. And they want them to be integers. So they're going to put that restriction on me. So they want those exponents to be greater than or equal to 0, and they want them to be no fractions, no decimals. They want them to be nice, well-behaved integers. You'll say, Professor, are you talking about back in middle school when I saw a polynomial function that looked like this? You've seen these before. I'll just create one right quickly. That's a polynomial function. That one has 4 terms. They want these to be all integers. And at this point in your math, you should know what an integer is. No fractions, no decimals, no square roots, nice, well-behaved integers, and they want them to be positive. Fit that description. Okay, guys? And that's the restriction. She gave that to me, so we will depend upon that. Now, what I intend to do, and then I'll look at that next handout. I'd like to, they start out in chapter 3 with you sketching one of these. Now, please tell me, if I gave it like this, my first example. Now let's make up one real quickly here. Can I classify that as a polynomial function? Yeah, it has 3 terms, it's a trinomial, but it's also a quadratic. We're very down with quadratics. They are also polynomial though. So guys, I'm not going to take the time to sketch this again. Now tomorrow on your quiz, you'll be sketching one of these for me. Like I did at the beginning of class today, is complete the square, find the vertex, intercept, so forth and so on, connect it, form the curve. As we were doing before the break, at the beginning of the class in fact. Now though, I have not with this class, I have not done one like this, and then we'll get to the handout. Sketch, well here goes, x cubed, subtract 2x squared, subtract 8x. I'd like to start out with that one before I get to the handout. Now, did I give you guys a second handout? I did, didn't I? Not yet? Oh, yeah. Oh, you'll have to. Okay. The second handout. Yeah, we're talking about this one. I'm not giving this one. Okay. Guys, please tell me, would you classify this as a polynomial function? Trinomial. It's a trinomial. I want to sketch it. Now, you say, wait, Professor, I know how to sketch this one. It's a quadratic. That's one you'll be seeing on the quiz tomorrow. But how about this one? Then I got to sketch and see what this particular cube looks like. Guys, here's what I want you to do on this one. And let me ask a student though. Does anyone see anything that might help me on this one that I'm going to start out with to sketch?
You can take out x.
Take out x. If I factor out x, just tell me something here that may happen. And I have that. Will that x squared subtract 2x subtract 8 factor further?
Yeah.
If it does, it would help me more. I think factors into, what's my factoring here? X subtract 4 times what? X plus 2. Now you say, Professor, just split those up and get your answers. Well, that's what we've been doing. No, I'm asking today, sketch it. Sketch match it. Oh, by the way, the zeros, they call them zeros now, the answers are 0, 4, and -2. We've done that. That's no problem. Now they want to see a sketch of this. So guys, let's go to a grid. I'll set you up for this and give the handout to you. We'll make this very, very easy for us. I'm going to pick up those zeros first since we know how to do that. My x-intercept, in fact. Then we'll call these zeros. And I think by this time, all the students can split these up and tell me the three values that will act as x-intercepts or zeros. And those are what? 0, 4, -2. And I'll place those on the grid at this moment. A little spacing here to make this look reasonable. And -2. Guys, at this point, I can say, well, I can at least have this to work with. Got -2, 0, and a 4. You could pick up the y-intercept. It's not very interesting in this particular case. What is my y-intercept? On this particular one.
0.
Well, of course it is, but you can find it. You can, well, Professor, I know how to find it. It's just not interesting here. You find f at 0. And I go through and replace all these x's by 0, I get 0. Which tells me, yes, that's my y-intercept. Very plot that. So there's my zeros, my x-intercept, my y-intercept. All you guys, the x-intercepts are known as the zeros, not the y-intercept. 0, 4, -2 are zeros. Now, does anyone have an idea? What does this look like? And I'll tell you ahead of time, and I think you know ahead of time. It's not a parabola. It's not a quadratic, it's a cubic. If you want to think of anything that might help me, even from this class, this winter, that might help me to get a sketch. Yes.
Would we go from negative up to -2 to like approach that intercept from the bottom?
Are you telling me there's a piece of the graph down here?
Yes.
At this point, the students tell me, Professor, I think there's a piece down here. I don't know yet. It goes up, and it's got cross here. It's going to cross here, go up a little height, come back down. I don't know how high it's going to go unless I plot points. Come back down, pick up that 0, drop down, may drop way down here. I don't know. It's going to come back and pick up 4, and then on above. It may look like that. Now, does anyone have an idea of how I can make sure? Yeah.
Would it be helpful to individually find like minimum and maximum?
I would, you know what? I wish if I were teaching Math 7, I would ask you to find the max and the min. I would ask you to find the max and the min on this cubic. That requires calculus at this point. Now, if I ask you to find the max and the min on a quadratic, we can do that. That's negative b over 2a. I don't have a negative b over 2a for a cubic. So I cannot right now at this moment tell you exactly where the maximum point is that's going to be on this graph, or the minimum point, if there is one. I can't do it until Math 7. Something else that we've done in this class that may help me get sketched. We've actually done here. In this class. Okay. I wish I could do transformations, but I can't. It's just not in the form to transform, because look at this crazy mess. Some students may say that means horizontally shift to the right 4, horizontal shift to the left 2. Professor, you want here and there and here and there? No. Not on a cubic. Yes?
Sign analysis?
Sign analysis. Sign analysis. That's why I kept emphasizing sign analysis all these weeks we've been together. Guys, to the left of -2, let me real quickly, please. To the left of -2, let's replace by choice some number. And we'll try -3. I'm not going to actually show you the test number like I usually do. A -3 would give me help me out now. A negative, and a negative. Now go through and replace those x's by -3. And all three negatives will give me as what? Negative. All I want to show is that it is going to be negative here, which does tell me something about the graph here shortly. In between these two zeros, let's try negative 1. Negative 1, negative 5, positive 1. Is it a positive altogether? Between 0 and 4, my next 0 down there, 0 and 4, goodness gracious, lots of numbers, try 2. 2, negative 2, 4, I think. Is that a negative? Is that enough to tell me, if I had no mistake, where the graph's located? Are we correct? Out to the left of negative 2, we got a negative for sign analysis. Does that tell me, Professor, I think the graph is down here, below the x-axis? Here, we discovered positive by sign analysis, which means, now guys, I'm gonna erase the positive to get my graph. That means it's above, so it's gonna go above. How high? I don't know, you don't know. It's gotta come back. So this little interval here, it's above, it's positive. All this came out to be by sign analysis negative. It says it's going to drop down. How far down it goes, we don't know yet, but it's going to come back and pick up that. Should I test something out to the right of 4 by sign analysis? I'll try 5. 5, what is it, 1 and 7? Is it all positive? So it says, Professor, continue. Now the next piece is above the x-axis. There's your graph. Not drawn to scale. Not drawn to scale. If I wanted a more specific looking graph, I could ask you maybe go on the side, form a table, like you did for the piecewise functions, and maybe try -1 to see what -1 replaced here would give you, and maybe try 2, see what 2 would, just out of curiosity, -1. If I was replaced by -1, guys, help me. -1, -5, 1. Is that a positive 5 altogether? So it says you go up to 5. That should be up in here somewhere, 5. If I try like 2, I mean, my graph looks like it's dropping at lower, I don't know. Let's try 2. 2, -2, 4. 2, -2, 4. Is that -16? -16? And sure enough, it would be down lower. You could try a few numbers, just get a better graph there. Guys, that's a pretty good graph of just standing here of this. We did 3 sign analysis. Now what I want to point out though, something a little bit quicker than using sign analysis. I love sign analysis though. But something might be a little bit quicker. I noticed the first term of this polynomial function, is that. That first term, a subscript n, x raised to the n, is going to tell me something ahead of time about my graph that I can quickly get done quickly. And some students may know what that first term is going to tell you. Guys, this is one of your parent graphs. It was on a handout I gave you guys. Does anyone recall what the x, not square, x cubed, basic x cubed graph looked like? I'm putting it in blue here. I'm putting it in black. Did it look something like this? Roughly. Does it look something like that? Does my blue graph do the same thing as that cube graph in black? Are they doing something alike, the blue and the black, that maybe I should be aware of? Someone describe for me, the blue and the black are doing what? Some similarity there between the two? What are they doing? Let me get it. Okay, I see that, something else. Oh yeah, somebody got here. Over here on the end of my blue graph, which we have graph, it was going up like this. Was my parent graph doing the same thing on it? They call that end behavior, on the end of both. Over on the left end, my parent graph was dropping down like this, the black graph, the cube. Was my blue graph also dropping down on the end of it? So if I take knowledge of, or see that, and have knowledge of that, That may help me also in graphing this. Now, someone mentioned max for men. Guys, there's a max in here somewhere. I just talked to one of my previous students at the door there. She's taking math 8. There's a max there. I should have asked her to come in and find it for us. There's a max there. I doubt anyone in class, unless you've had some calculus, could tell me specifically what is the highest point right there called local max. And there's also going to be a local min. Does anyone think they use it? Has anyone had any calculus? No. I can't show you. You have to use calculus to find that local max or local min. I'm happy if you just plot a point maybe and get, yeah, professor, this is a little high here, this drops down way low here. That would make the graph look better. The graph's done. In other words, it's finished. No problem. Now I'm going to describe a few things on this graph. The zeros we got out of the way. Zeros are 0, 4, -2, the x-intercept. Now this end behavior. Describe it to me. What's my graph doing out on the ends? Here goes. I'm going to write this up as your textbook does, and then we'll use some calc notation. My blue graph, as, on this end, as x gets large, it's approaching infinity. In other words, on the x-axis, you keep going this way forever. What are you guaranteed my blue graph is doing? As I go this way forever, and that graph is being pulled along with me, I'm going this way forever, that's what this means, on the x-axis, forever. And now look back and say, well, where's the blue graph? Now I know it's here, but it's also being pulled along with me. What's it doing? On that particular end there, what's my blue graph doing? Is it rising? Continuum? Is it going to stop or not? It goes forever. So my function, p of x, the graph, is also in this case approaching infinity. It's rising. On the other end, over here, it's like this. As x is approaching negative infinity. We're on this end, blue graph. Guys, as I go out this way, I stop at -2, but -3, -4, -10, -100, -1,000, and I keep going. As I keep going, PK, this graph also keeps going. Where's it going? The blue graph. Is it dropping down forever? Expressed as my function is approaching negative infinity. It keeps going forever. Dropping down. Now the calc, this is what you guys will be moving to math 7. The calculus expresses it like this, the geographer. They write it as limit, abbreviated L-I-M-I-T, I'm using the word limit in calculus, abbreviated L-I-M, limit. As x is approaching infinity, written underneath here, of my function, and then you give the answer. That's how the top one looks in calculus. The bottom, Mr. Park, June, make sure I have all this written correctly. Limit, as x is approaching negative infinity of this function. Looks like we got an answer of negative infinity for it down there. That's the way it looks in calculus. We're talking about a limit. Your text says as x is approaching. I prefer just limit. Same thing though. Okay, for end behavior. So I got the end behavior out of the way. I got the zeros out of the way. Let's answer one more question and I'll get the handout to you. Let's answer this, let's call it this. Anyone tell me when am I guaranteed that this will happen? When am I guaranteed that this function in black, or in the factor form of the blue, for what x's am I guaranteed that you may replace x by them? You're guaranteed that we'll get a positive answer for this entire function. What does that mean? You can look at it, quickly find that set of x's that will make that happen.
4 minus 2 to 0.
Oh, you already said it. Come again.
4 minus 2 to 0.
Now, why did you say -2 to 0, Professor, if you have the graph? Tell the class why you said this.
Was it step off?
It's above the x-axis, implying it's positive. That's what I'm looking for. So he is correct here, -2 out to 0.
And from 4 to
Look at this. Doing calculus here. 4 through infinity. I'll just put union. 4 through infinity. Are you ready for the question? Guarantee you, I don't have the time. I think I've done this many times with you though. Guarantee you, if you take a number of your choice, let's say for an example, in that second interval he gave me, I don't care what number you try, 10, 100, 1,000. You take it back and put it in here, or here, you're guaranteed to get a positive answer. Guaranteed. Your function will give you a positive answer. Okay. Guys, I think that's enough to get us started, but let me jot down before I give you this beautiful handout. Hang on. Am I ready for this? Oh, wow. Okay, here goes. I'm excited about this. Okay. Yeah, I get this review first. First one, when you finally get this, looks like this, and I'll leave this on this board here. I want to get a sketch of P of X is equal to ready? Why not? I'm not going to jump into it like this. Whoa, I am. Here goes. -1/2. X plus 1. X subtract 1 squared. X subtract 2. Step back a little bit. Make sure this copied down correctly. It looks like it is. And we got a sketch. Thank goodness they factored this for me. They gave it to me in factored form. They did not give it to me as I gave you this one. You get factored yourself into blue. No, they gave it in factored form for me. And they want us to sketch it. What on earth does the graph of that look like? Okay, Mr. Park? Now, can you help me out?